right, I want you to take out that sheet of paper, and I want you to draw a circle the best you can. Draw a circle. This is what you're gonna do tomorrow when you come in. You're gonna get a blank sheet of paper, I'm gonna give you a circle, and this is what you're going to do. Are you ready?
Is the circle already gonna be on there?
Or are we gonna have to draw a circle?
Okay, now, what I want you to do with me is I want you to write this circle in degrees. This will help you. Where do you start with? Right here.
0 to 60.
What's at the top?
90.
Then,
270.
then,
270.
and 360. Okay. What's the angle in between 0 and 90? What's half of that?
45.
So all of these are 45. So can we go through and put all the 45ers in? 45. Add 45 to 90, what do you get? Add 45 to 135, you get 180. Add 45 to 180, what do you get? Add 45, add 45. What's this? Okay. Now, if I didn't have these 45s in here, if I broke these up into 30, you have how many? 30, 60, 90, can you do those? 30, 60, 90, 120, 150, 210, 240, 270, 300, and 330.
Let's screw that circle.
Are you guys with me on that?
Yeah.
Yes or no? Yeah. All I did was add 30 to each of those. Questions? Okay, next. I want you to do, let's do the radians now. I think I will do it in, this is 0 or 2 pi. What's at the top, or what's 180? Pi. So what's 1/2 of, so you got that one. Do you know what this one is down here? 1.5, and then that's 2. Now, if I break this up into quarters, you guys remember what this one's called? Not 4 pi, pi over 4. So each of these is a quarter. So you have 1 quarter, you have 2 quarters. What's 135? 3 quarters. Then you have 4 quarters. 4 fourths is pi. Then you have, what's this one? 5 quarters. This is 6 quarters, but you don't need to write it because it's already there. And this is 7 quarters. And 8 quarters. What do you notice about all the quarters? They have a 4. Now, we're not going to label the 45s. We're done with those. What is the equivalent? If we looked at this, this is 1 pi from here to here. How many sections are you coming up with? Here's 1. Here's 2. So 1, 2, 3, 4, 5, and 6. So this is pi over 6. It's a 1/6. This is 1/6. And this is going to be 2/6. Or pi over 3 if you reduce it. This is going to be 4/6. If you reduce it, it's pi over 2. This is going to be, so 1, 6, 2, 6, 3, 6. This is 4/6. This is 5/6. This is 6/6. This is 7/6. This is 8/6. 9/6. 10/6. And 11/6. Now the 6s are really, can be, these ones that we did can be reduced as thirds. So you could think of this as 1/3, this one's gonna be 2/3,
Can you write them as both? Does it matter?
huh?
Like,
Yeah.
if you-
Yep. 2/3, this one's gonna be
4/3.
4/3. And this one's gonna be 5/3. I think if you can do that, for me, you'll be able to get a very good grade on this test. I think that will help you. Now, the other things that you need to know for this test are the special triangles and the definitions. So, let's talk about, if you have a 45, 45, 90, you guys know the ratio?
1, 1, 2.
Yep.
Yeah.
What about a 30, 60, 90? 1, 2, √3. You need to know that. You also need to know what's the definition of sine.
G.
Opposite over hypotenuse. Is there another definition?
Y over R.
Well, yeah.
Y over R. Know them both. What's cosine?
X over R.
Which is
Adjacent over hypotenuse
X over
or
R.
X over R. And tangent.
Opposite over adjacent or Y over X.
Opposite over adjacent or Y over X. Now, when do you use the words opposite and hypotenuse, and when do you use X and Y?
When it's a 90-degree angle or one that falls like, roughly on the line, you use coordinates like Y over R and X over R.
If you are here, this is 0, 360, 2 pi, any of those kinds of numbers, you're gonna use 1, 0. Think of going from the origin, you're gonna go 1 unit to the right and up 0. So the X value we're talking about is 1 and the Y value is 0. When you're talking about 90 degrees or pi over 2, you're gonna talk about 0, 1. When you're at pi or 180 degrees, you're thinking of -1 comma 0, sorry. And if you're at 270 degrees or 3 pi over 2, you're thinking of 0, -1. So if I say what's the sine of pi, well, pi is 180, and sine is y over r, and by the way, r is 1. Think of r as always 1 here. So, what is the definition of sine? It's the y value over the r value. What is the y value here? It's 0. 0 over 1 is 0. The two undefined ones are tangent right here. These two angles are undefined for tangent only. Because when you do y over x, you get 1 over 0, which is undefined. Those are the only two undefined. Now, what if it's not on the x or y axis? What if it is one of the other angles, like 60 degrees or 3 pi over 4? What you're going to do is you have to have a really good understanding of this circle and understand that when you're finding out the sine or cosine of an angle, if it's not on an x or y axis, you are going to make a triangle with the x-axis. So if I ask you, what is the sine of 3 pi over 4? Sine of 3 pi over 4. Where is 3 pi over 4? This is 3 pi over 4, right here. So what you're going to do, here's 3 pi over 4, it's a 45, you make a 45 degree with the x-axis. So I know I'm in quadrant 1, I'm going to use the special triangle 1, 1, √2. But in quadrant 2, x is negative. So when I ask you what's the sine of 3 pi over 4, you do opposite of this angle, opposite over hypotenuse is going to be 1 over √2. If I ask you what's the cosine of 3 pi over 4, well, cosine is adjacent over hypotenuse, so it's -1 over √2. if I asked you something like 7 pi over 6, 7 pi over 6 is in this quadrant 3. So you're going all the way here. So what you're going to do is analyze this little angle that you have, this little triangle. You're going to draw a triangle in quadrant 3 with the x-axis. So where is 7 pi over 6? This whole thing is 7 pi over 6. So we're going to analyze this triangle right here. That triangle, 7 pi over 6. We're going to use this angle. Can you tell me what that angle is?
210.
No, I don't want that. I want this angle measure.
Oh, it's 30.
It's 30, so pi over 6, or 30, yes.
How do you know if it's a 30 or 60?
Well, if you have, from here to here is 7 pi over 6, right? And this is pi. From here to here is pi. So if you took 7, from here to here is 7 pi over 6. If you remove this portion, which is 6 pi over 6, you get pi over 6. This is pi over 6 right here. If you subtract this piece right here. So in other words, this plus this gives you 7 pi over 6. Well, this we know is pi, and this is going to be a sixth. And 1/6 pi is 30 degrees. So I'm going to name this side -1, this side -√3, and this 2. Why did I make these negatives? Because you're in quadrant 3, and in quadrant 3, x and y are both negative. That's a 30-degree angle. The side opposite the 30 is a 1. This is a 60. The side opposite the 60 is √3. So if I asked you what the sine of 7 pi over 6 is, what's the cosine of 7 pi over 6? Or what's the tangent of 7 pi over 6? Well, you're going to use these ratios. Sine would be -1/2. Cosine would be -√3 over 2. And tangent would be -1 over -√3, which simplifies to 1 over √3. Next year in pre-calc, you're going to be forced to rationalize the denominator. You'd write this as √3 over 3. Okay? Are you guys with me?
Yeah.
So that's very important. I wanted to stress that today. We're going to go over that in a minute, but take out your partner test, and I want to go over that with you guys.
Tomorrow, which one's the name?
So tomorrow, you guys will do really well in this test.
I can't believe that you didn't fill out the graph.
Okay, so, question number 1. Using this ordered pair, -1, -√3, how would you figure out what this angle is right here? Well, I know it's 180, from here to here is 180. So it's 180 plus this angle right here. Well, according to these points, this is -1 and this is -√3, according to this ordered pair. So this angle is across the √3, so this angle is 60. So what is 180 plus 60? 240 degrees. Okay, next one. What does it mean when you have two of the same numbers?
45. It's 45.
This is a 45-degree angle, which means this is 45 and this is 90. So we want you to measure this angle going backwards. So what is it from here to here?
-135.
-135. And the last one. If we multiplied both of these sides by 2, this would be √3, actually -√3, and this would be 1. So this angle, this little angle right here is 30. So how would we measure from here to here? It would be 180 minus 30, which is 150 degrees. So from here to here is 150. Number 4. How do you draw a 225-degree angle? Well, it's somewhere in quadrant 3. So you're gonna do that, arrow. That's it. The next one, negative 120. It's going this way. And 395 is gonna be once around, that's 360 and then some. That is 395 degrees. Number 7, I want a coterminal angle that's between 0 and 360. So this one, you're gonna subtract 360, what do you get? This one, what are you gonna do? Subtract 360, and what do you get? And this one. You're gonna add 360, what do you get? You get negative 45. Is that between 0 and 360? No. So you gotta do negative 45, you gotta add another 360, and the answer is 315. Okay, this back page is where you're really gonna need to know that unit circle, the one that we just drew. So I'm gonna do them each separately. 150 degrees, and refer to your circle. Where is 150 degrees? So here's 150. I don't really care about 150. I just need to know what quadrant it's in. I'm interested in this, the angle that you make with the x-axis, which is 30. The 30 is important, and the fact that it's in quadrant 2. So the side opposite the 30 is 1. This is going to be negative root 3, and this is 2, because it's a 30, 60, 90. Now you got to know the definition of sine. Sine is opposite over hypotenuse, so 1 and 2. Anyone not get that? Next one. Where's 180 degrees? Right here. What's the definition of cosine? X over R. What's the x value?
-1.
There's your answer, -1. How about 45? Where is a 45-degree angle? We're going to name these sides 1, 1, root 2. Tangent is opposite over adjacent, 1. Tell me where 240 degrees is. So it doesn't have to be exact, but from here to here is 240. So what is this angle right inside here? I need this angle right here.
60.
So you're going to subtract 180 and you're going to get 60 here. So then this means this is negative root 3, this is negative 1, and this is 2. So the tangent would be opposite over adjacent. Can you simplify that? Root 3. Next one. Where is negative 120 degrees?
Set to
This is negative 120. So what's this? I want an angle with the x-axis.
60.
This is 60, sorry, it's a little crooked. So again, what quadrant are we in? 3. So this is gonna be negative, this is gonna be negative, and this is positive. So what's the sign? Opposite. You want the opposite of this angle, 60. So negative root 3 over 2. Where is 135 degrees at? It's 45 in quadrant where? So this is 45. Can you name these sides? This is the error that people make. They write 1, 1. If you do 1, 1, you're giving me the cosine of 45, not 135. So this answer should be negative 1 over root 2. Okay, where is negative 225? And if you don't know, you could do what? Add 360. What do you get?
135.
If you did 360, you get 135. So what you're gonna do is, that's again a 45 in quadrant 2. So from here to here is negative 225, but here to here is 135. Regardless, this triangle is a 45 in quadrant 2. So you gotta know these ratios. So what's the sign of that? It'd be 1 over root 2. Number 17, where's 90 degrees? What's the definition of cosine? What's the x value? What's 0 over 1? Yep. How about 90 degrees? And we're going to talk about tangent. What's the definition of tangent? Y over x. What is the y value here? What's 1 over 0? Good, undefined. If you tell me 0 on that one, it's wrong. Number 19, where is pi over 4? What's the sign of pi over 4? What angle is pi over 6? What is it? It's a 30. What's the cosine? Is root 3 over 2. Adjacent over hypotenuse. Where's pi over 3? 60. Opposite over adjacent. Where's pi? Sine is x or y?
Y over R.
What's 0 over 1? Good. How about pi over 2? Cosine. X, 0 over 1, which is 0. And the last one, where's 2/3 pi? There's 2/3. So what's this angle right here?
60.
So a third, or, yeah, pi over 3, 60. So this is gonna be root 3, negative 1 and 2. So the tangent would be root 3 over negative 1. You get this?
Yeah.
Okay, next. How do you convert degrees into radians?
Dimensional
We do dimensional analysis. I couldn't say that. So what do we want on the bottom? We want these bubbles to cancel, right? And you're gonna put pi, because you have to understand that pi is equal to 180 degrees. So now, if you use your calculator and the fact that you can use reducing, you get 7 pi over 4. Now, that's the answer in radians. How do you do it without pi? Express the answer without pi as a decimal. If you do 7 times pi divided by 4, you should get 5.49 radians. So these are two good answers.
Do you need it multiplied to the pi?
You know what, we didn't do too much of this, the radian stuff in class, so I kind of let this go, this one. But would you all be able to do 7 pi over 4 in radians without the pi, using a calculator? You do 7 times pi, 7 times 3.14, and then divide that answer by 4. That's all it is. Huh? You were supposed to, if you can read the directions, express the answer in terms of pi, and also as a decimal round to the nearest tenth. So it should be 5.5 actually. Number 26. You're gonna take negative 450, and you're gonna multiply it by pi over 180.
Yeah.
They're not asking you for a code terminal. They want this answer in radians.
Yeah.
Your answer is negative 5 pi over 2. or negative 2.5 pi. And then how do you convert that into, calculator?
Can't do it in your head.
What's
I'm kidding.
negative 2.5 times pi is negative 7.9. Next one. How do you write the degree of this one? So 5 pi over 3. What you're gonna you want pi now on the bottom, so 180 goes on top. These cancel. How many times does 3 go into 180? 60. 5 times 60 is 300 degrees. 7 pi over 4. And I want to see this work. The pi's cancel. You can multiply across and divide and you end up getting 315. Next one, 29. Please tell me how to graph this.
You go down 3, right?
I want to see, at negative 3, I want to see a broken line, and I want to see some nice graphs
What do you
here.
call that? It's not nasty.
It's your new x, we call it the new x-axis, okay? Now, what does the cosine graph look like? Does it start above that x-axis?
Above.
It starts 2 above if it's positive. So it's gonna be above, on,
Below, above. Do you want it reflected over the y?
okay, read the directions, what does it say?
I don't. Okay.
It says, I want you to graph from here to here. So that means yes. I want you to go the other way. I gave 3 points for that. I looked for, was it shifted down 3? Is your line there? Is it 2 above? Is the amplitude 2 and did it start above? Some people did the sine curve here. They started here and went up 2. Nope, it says, according to this, I only want you to graph from there to there, stop. No more, no less. Next one, where do you start? Now this is the sine curve, but it's an upside down sine curve with an amplitude of 3. So I know I start on, do I go 3 up or should I go 3 down? 3 down because it's backwards. Now, look at your graph, it should be very, like, even. I had some people that did 2 small lines and then 2 big ones. No, that's not how it goes.
Nope.
How about the next one, -1? And then this is an upside down cosine curve with, the amplitude is 1, so you're gonna start 1 below. On. This one looks like a bell, right? And stop. That's all I wanna see. I don't wanna see you add anything to it. Done.
I have a question.
Yes.
On the test, are you gonna make it so we have to adjust the scale of the graph or the presentation?
It's gonna look just like that.
Okay.
Now, these
Yeah.
three are a little different. What do you have to do?
You have to put your new x.
Okay, I wanna see you fill this out. Amplitude is what? 2. How do you do the period? It's always 2 pi over b. Well, what is b in this case? So it's 2 pi over 2. What happens to these 2's?
Cancel.
They cancel. So it's gonna take you from 0 to pi to get through 4 complete increments. How many increments are there? There's 4. You take this period and cut it into 4. And then this is 3 down. So how do you put, I looked for this, and now I wanna see you label your graph. What are you gonna start with? You're gonna start with pi over 4, 1 pi over 4, 2 pi over 4, 3 pi over 4. You guys are gonna do so well on this next year. Negative pi over 4, negative 2 pi over 4, negative 3 pi over 4, and negative 4 pi over 4. Now, where do you start? 3?
Below.
Mm-hmm. And then do what? You start on. Can you make it neat, you guys?
Almost.
And it's curvy. I saw some of you guys make pointy. It's very curvy. Next one, number 33. What's the amplitude?
2.
Just 2. What's the period? You're gonna do 2 pi divided by a half. What's 2 pi over a half? Good job, 4 pi. Cut this into 4 parts. What's 4 pi divided by 4? Pi and 1 down. So how are you gonna count? You're gonna count by pi. So your graph should look like this. 1 pi, 2 pi, 3 pi, 4 pi. Negative pi, negative 2 pi, negative 3 pi, negative 4 pi. Now what do I do?
Start below.
1 down. Now I'm gonna be grading like 80 of these, so please be neat, you guys. How do you graph this sine curve?
Start
You're gonna start on, should we go 2 up or 2 down?
down.
Good. I want 2 full periods, just like that. And the last one, help me out. What's the amplitude? This one was a little harder. Amplitude is 3. How do you do the period? 2 pi over, what's the b value?
4.
Can you simplify that?
Half pi.
I had some people write 2, they wrote this, but then they wrote 2 pi. 2 pi over 4 is a half pi. Now how do you cut this into fourths? How did you do that? I multiply, when it's a fraction, I multiply. And it's a shift to up. So how are you gonna count? And I'm sorry, it's gonna be off the page, but we're gonna write real neat. Can you do this for me? You're counting by 8s. So it's pi over 8, 2 pi over 8, 3 pi over 8, and 4 pi over 8. Negative 1 pi over 8, negative 2 pi over 8, negative 3 pi over 8. And now what do you do? 2 up. And you're gonna start on and go 3 up. Anybody have any questions on how to do these? Does anybody have any questions on how to create the circle graph? And the angles, and the radians, and what the definition is? Yes, both of you guys have your hand up. What's up?
Okay. Tomorrow, is it gonna be like the last test where we walk in, we have to draw the sort of graph, and we use that for the rest of the class?
What I think I'm gonna have you guys do, I'm going to give you, so there's no